conference, for including me. I'm here to talk about how machine users are now users that we want to consider when we're developing applications for AI. So we're really going to talk about intelligence and what distinguishes us as humans and how we can integrate that in with intelligent applications. Here's a little bit about me, because I look at the roster here and I'm like, how did someone like me who just has a master's get involved with such a talented roster? But I've been involved in information architecture for quite some time. I'm a consultant for a multinational software company. I deal a lot with personalization, and I'm a little math phobic, but I'm determined to incorporate more human factors professionals in the development of artificially intelligent systems. And the purpose of this presentation is to tell you why and bring you along on my journey. I love this cartoon as it ideally represents the human and artificial struggle with intelligence. Human intelligence is complicated, integrated with external and internal influences. Meanwhile, AI goes merrily along, carefree in its scoped training and single-minded purpose. When we look at the hierarchy of needs, we see that human needs are influenced by feelings, engagement, values, and moral codes, whereas AI is influenced by data, and then programming. Part of our intelligence involves sense-making, and in the current world, that's about shaping knowledge flows and reading context. Reading context is different than reading signals. Data is signals. Data is not information because it doesn't incorporate the beliefs and values that bring context, that bring sense. And that's why we're all here. Autonomy is another unique human characteristic of our intelligence. It's associated with free will. Computer programs can't act outside of instructions unless the instructions include develop your own independently formed motive, and they rarely do. Computer programs are closed systems, and the processing is limited by initial and encountered boundaries. Embodiment is also a unique human characteristic. It's our unique capacity to form a web of relationships between lexical concepts and semantics that are derived from being in the environment and cannot be computed. You cannot algorithmically tell a system what it's like to feel the wind on your skin. That's unique to us. So machines can't form second-order representations, relationships between concepts and thoughts that enable compositionality, which is the ability to stack concepts on top of each other to form bigger concepts from smaller ones. And then there's experience. And experience is unique, and as we can see from the slide, some of them are a little more memorable than others. Julio Tononi, and I apologize for misrepresenting his name, has developed a theory, the integrated information theory, and he maintains that there are 5 principles of a conscious experience. There's intrinsic existence, that it's internal and individualized, mine, not yours. There's composition, that means it has structure. There's informative, it provides information that is used to build knowledge, that it's integrated and based on interpretations, and that it's exclusive and defined. And that leads us to the ultimate goal, which is consciousness. Consciousness is very difficult to define, and many have tried. My guidance comes from David Gelernter in his book, Tides of Mind, where he talks about how the human mind is not just a creation of thought and a collection of data, but it's a product of feelings, a composite of sensations and memories and ideas that are worked and reworked over a lifetime. And Melanie Mitchell, in her excellent Artificial Intelligence, A Thinking Guide for Humans, tells us that consciousness is our entire conception of self and comes from our ability to construct and simulate models of the mental models that we acquire through intuition and experience. Most importantly, we're irrational, and that's what distinguishes us. Computers are logical, exacting, context independent, and they use conditional logic. But it is the irrational behavior that has gotten us where we are now, some good and some bad. I always use the example of Google here, where in 1999, Google debuted a search engine that had a single box on a white background. That was absolutely antithetical to everything that existed at the time, and yet proved to be wholly and totally popular, and now is the mainstream for what we have with online information retrieval. However, today, Google would not approve that design because there's insufficient data to support its success. And speaking of data, we are the training data. Users share private information in exchange for things of perceived value and based on an assumed social contract that is oftentimes not upheld because the data is shared and aggregated and becomes training sets for artificially intelligent programming. Here are some of the key data points, along with what you buy and where you purchase and what you return and how long it's taken you to come back, and your public records and your, your personal postings and your social profiles, and all of that becomes a consolidated profile that the system used to better understand human nature. So how do we design for humans? How do we design for machines? And how can we incorporate that? Well, Harry West, who's the former CEO of Frog Design, one of the top design firms in the world, tells us that human-centered design has now expanded to include the design of objects, so industrial design, and the design of experiences, interaction, visual, and spatial design. But the next step, he tells us, is the design of system behavior, the design of algorithms that determine the behavior of automated intelligence systems. Where do we start? I advocate that you start with developing principles that are the objectives and goals and end state that you're shooting for. I also advise that you attach notes to that include system rules, logic, rewards, and feedback loops. The principles are going to make sense to the human factors, people at the table, and the notes are going to make sense to your developers. And together you will develop a framework that guides the project. You also want to create an empathy profile. Everyone has their personas, and these are archetypes of the typical customer and what they do. However, an empathy profile incorporates the qualitative components that differentiate shared experiences, synthesized beliefs and values with the tastes and preferences. And you do this by defining the solution, understanding the problem-solving options, defining the characteristics of a good solution, the heuristics, and then mapping the environment, that customer journey, and benchmarking success. So a normal customer journey map, a human customer journey map, focuses on instinctual actions. The phases are influenced by thinking, expressing, and acting. The stages are context-based. I'm advocating that you develop an AI journey map that must be programmatically explicit, as the AI lacks intuitive movement. AI uses decision trees for journey progress. You need to map those decision trees out. It requires a massive amount of data that you will want to review. There are explicit decision sequences that you'll want to face and again map out, and also incorporate iterative development. In a more lengthy, and there are notes in the slides that I hope will be available to you. You want to use good data, and that's complete, accurate, consistent, and timely. Know where it comes from. You want to create interfaces that capture actual situation behavior, that maximize the instructions to the machine learning or AI program to become part of their learning decision tree. You want classification for inputs and effective labels that will work across systems within your organization. You want to enable design of interactions that can restate the understanding of the task to be performed. The system has to be able to restate what's going on. And you have to provide fallback through conventional user interfaces that allow the user to bypass machine learning for a logic that is implicit to them alone. Test the software across many environments, and most importantly, create a baseline to measure no-go if a system failure would create serious consequences or irrevocable change. Be on the lookout for heuristic traps, and they're out there. There's the familiarity trap, which is failing to be vigilant when faced with the unknown, providing false confidence. There's the social facilitation heuristic track. Everyone's doing it, so it must be okay. Well, tell that to the guys in the back of this line to get on top of Everest that are running out of oxygen. There's the expert halo, the false confidence in experts that we assume know what they're doing, so it must be okay to follow them without question. Always question authority. There's anchoring, consistently clinging to a position because you always have. As the Donner Party famously found out, every moment you don't turn around, it becomes harder to do so. And that has absolutely got to be true in the development of AI and ML applications. There's scarcity. In the skiing world, this is known as powder fever. It might be gone later. If I don't do it now, I never will. And this one's for my mom. If everyone else jumped off the bridge, would you jump off the bridge? I heard that a lot when I was a kid. But if the cool kids are doing it, we all want to be like the cool kids. So let's just do it. Let's just follow the crowd. The other caveat, the other thing to look out for is that technology is not neutral. I love Monty Python, and I use this analogy frequently. Nobody expects the Spanish Inquisition. Nobody expects the unfortunate outcomes from the application of artificial intelligence. And let's look at a couple of those. There's algorithmic bias. Ben Schneiderman, who is the winner of the ACM Turing Award, calls for a national algorithms safety board to monitor and assess the safety of algorithms as they assess social systems. There is no universal governance as existed at the beginning of the AI emergence in the 60s and the 70s. Do not accept decisions from automated systems as agnostic just because they're not sporting QAnon insignias or signals. Technology inherits ideas and values of the group that develops it. And algorithmic development rests on emotional capitalism. Oftentimes, the belief that suffering is unavoidable and should be tolerated to accept a better outcome. There's adversarial AI, and we've heard a number of examples of this. A GM automobile online computer was hacked, causing it to stop in the middle of the roadway. Someone hacked into a refrigerator and took down the internet using a denial of service attack on a hub. There are badly designed objectives. Again, my favorite, the Donner Party. Who made a number of bad decisions along the way in deference to the intent to make California before snowfall in the Sierra Nevada mountains. They did not make that deadline. They got trapped in the mountains, and there were very tragic consequences as a result. There are the narrow use cases. It's very difficult to code all shades of a skin color. When Google first launched its AI for image recognition, They did not code sufficient colors of African American skin. As a result, 2 individuals were identified as gorillas because of the algorithmic logic provided an alternative. If the human determination is not supported by skin shade, do this. What could possibly go wrong? There's poor extrapolation of the real world. Microsoft decided it wanted to train its chatbot to talk like a real human. So it set it loose on all of Twitter for 24 hours. And at the end of that time frame, the chatbot came back as a racist, foul-mouthed misogynist. There are misaligned objectives. This was built as proof of concept for AI gone wrong. They used bias data, which was the subreddit dedicated to the disturbing realities of death. We can only imagine what was in there. This was built by the Media Lab at MIT. There are the unexpected outcomes. At Facebook, 2 teams independently developed chatbots that then developed their own language and started communicating with each other in a manner that was not discernible to the humans. We do not need to be benignly the recipients of these errors. We can participate and should participate in the development of these systems. We can bring objective functions to capture the designer's formal intent with no partially observed goals, by providing concrete and abstract rewards, and by creating a deep correlation between tasks and functions. We want to have well-defined models that are trained on multiple distributions and programmed for out-of-distribution situations. We also want to define and train impact regulators so that a future state can be imagined, as well as separate the training parameters from the task side effects. We want safe exploration with risk-sensitive performance criteria and simulated exploration. We want feedback loops with a model look-ahead reward capping. We want to penalize influence by using information theoretic measures to capture the agent's potential for information, penalize empowerment, and program to avoid reward hacking. Neil Postman is an incredibly well-regarded American educator. And in 1993, he gave us, I think, are still stellar guidelines for technology development today. He said that all technology change is a trade-off. The greater the wonders of technology, the greater will be its negative consequences. And culture always pays a price, as we have seen with algorithmic bias and the social psychological impacts. The advantages and disadvantages of new technologies are never distributed evenly among the population. Some gain and some lose, but few remain the same. As we've seen and recently with distance learning here in the United States, and 2 little girls sitting outside of a Taco Bell to use the free Wi-Fi because they don't have Wi-Fi in their home. Number 3, embedded in every technology, there is a powerful idea, sometimes 2 or 3. Let's make sure we're looking at all of the powerful ideas before we release the technology, and not just the profitable ones. 4, technological change is not additive, it's ecological. A new medium does not add something, it changes everything. And we are seeing the unintended consequences of that, some of which are unpredictable and irreversible. And last, media tends to become mythic. This is a particular favorite of mine, as is Jaron Lanier, who has promoted a theory called computationalism. He believes that enthusiasm for technology sometimes becomes a form of idolatry. And we see that now with AI as the new hammer, and everything is a nail. Its capacity for good or evil requires human awareness and participation. human factors professionals included in the development and execution and planning. In a previous life, I worked in the entertainment business, in film in particular, and I'm drawn to this quote by Richard Silbert, who has designed some of the most beautiful movies, Chinatown, Reds, Cotton Club, to name a few. Technology will always benefit from having humans involved deeply because we are the vision. Not only that, we're the fantasy, and we need both. So what are the key takeaways here? I'm hoping for you. Broaden your scope of awareness. Understand the landscape and the influences. Embrace the new tools and methodologies. Keep reading those articles until you understand them. And then look beyond the bottom line. And in doing so, we will be able to embrace, engage, define, and then direct these applications and avoid the robot apocalypse. I've included some Twitter resources that I follow that have furthered my education on this. And last but not least, I aspire to when we can also program kindness into these applications. Thank you very much. I'm going to stop sharing.
Any questions? Let's wait for a couple of minutes.
Wow, I stunned them into silence. It's lunchtime.
Okay, yeah. Yeah, we
They all want their lunch.
Just one announcement, like we have mentor sessions. I posted the links, whichever mentor session you want to join, you can join that link at 12:45.
Thank you so much. It was a pleasure joining you today.
Sure, fine. Thank you.
Bye now.